Hi, I'm John Paul Raj, and this is part 9 of the complete solution series from May 2025 IB Math AI Paper 1 HL Time Zone 1. Let's roll the intro. So this is question number 9, and this question is on normal distribution. Typically, what happens in a question on normal distribution, you'll see, at least the part B or one of the sections in, if there's ABC, one of the sections will be something to do with binomial. So even if it says normal distribution, pay attention, okay? So you might be studying, when you're studying in class, actually, you have questions on normal distribution and you learn the calculator syntax on normal distribution, but you got to be careful how to write the variable, even if it's not mentioned. Like in this question, they have not said anything like, sorry, that was the calculator, switch to the wrong screen. Let's get back to the right screen. There you go. This is a question. It says, in a year, Louis attends school for a total of 180 school days. Louis leaves his house at exactly 7:45 a.m. every day and takes public transportation. As you just skim through the question, there's no X or Y, the random variable, okay, the notation. So if you directly, write something like, probability of X and whatever greater than or equal to 4 or something like that, I'm just giving you, you need to put a reference to this. Typical IB things, okay? I don't know why the title is there, just get rid of it. So this is what I mean by defining your variables correctly. And so if X is something that you defined as a normal distribution, then somewhere, as I said, if the question, you have to use a binomial, then you need to introduce a new variable. And those are the tips I want to share right at the beginning. Make sure that you write your variables and define them correctly. What is X? What is Y? If there's more than one variable, make sure, and then use appropriate distribution. X is a normal distribution, Y is a binomial, whatever that is, okay? But the point that I'm trying to make is that questions like these, which haven't clearly identified the random variable in terms of letters or symbols, then you need to define them correctly and use them correctly. And I think this is a great question to see that happen, okay? So those of you who are reviewing this, keep an eye on that, okay? And just making sure that how you write the answer, that is more important than just the answer, okay? As I've always said, answers are available readily for you guys on marking scheme online. You can just go and find it or put it on some AI tool. But my videos, I just thought I'll give you those extra tips, and therefore they are a little too long. If you find it boring, then find some other video. But if you have tips for me to improve, then do make sure you write something on the comments, and I will definitely read your comments, okay? So let's get on with this. I'll just erase this part. And because there is not much space here, I'll have to make sure that I write here and find some space. All right, let's read the question again. In a year, Louis attends school for a total of 180 school days. That's an important piece of information to keep in mind, okay? Total number of school days is 180. Louis leaves his house at exactly 7:45 a.m. every day and takes public transportation from his house to school. He travels by whatever the local transportation is, public transportation. His travel times are normally distributed with a mean of 35.5 minutes and a standard deviation of 5.2 minutes. The travel times are independent of each other. So basically that means that, each day, what time he travels or how much time he takes, that is independent of what happened the previous day. So the travel times are normally distributed. So how I'd write that? But let's just go on and read what they are asking us to do in part A. He is late. Louis is late if he arrives at school after 8:30 a.m. So basically what's happening is that every day he's leaving home at 7:45 a.m. So that's like, 45 minutes or more, okay? Exactly at 8:30 a.m. I don't think he's late. After 8:30 a.m. So more than 45 minutes, all right? So find the probability that Louis is late on at least 10 days in the year. So it's great. Right at the first part, they have kind of combined the two ideas. They've said something is normal distribution, but it looks like part A, you got to use something to do with binomial. So watch very carefully how I'm writing down, okay? So what I'm going to do is that in part A, I'm going to say, let X be the random variable, representing the travel times, Okay, I'm trying to use as far as possible the vocabulary given in the question. So, get into a habit of doing that, okay? Because they said his travel times to school, travel times to school, travel times to school by Louis. All right. X represents the random variable. Let X be the random variable representing the travel times to school by Louis. Is that right? Okay. Then X is approximated by the normal distribution. What have they given? 35.5 is the mean, comma. The standard deviation is 5.2, and when you write it down, you got to write down the variance, okay, square of the standard deviation, okay? So 35.5, 5.2 is the standard deviation. Remember it's sigma square, which is the variance is what you got to write. This is the correct notation. You got to put this thing down, okay? This is important to express what they've given the question in terms of that. So that's the random variable X, and X is normally distributed was what they're saying. Now, what have they said in the question? He's late if he arrives at school after 8:30 a.m. All right, so probability that he's late would be something like probability that Louis is late to school is equivalent to finding the probability of X greater than 45, okay? Because equal to 45 would mean that that's 8:30 a.m. So 45 is basically, he's leaving home at 7:45, and 8:30 a.m. is, the deadline at school. So we got to find out what is the probability that X is greater than 45. So we are going to switch to the graphing calculator quickly, and if I can just get rid of these windows that are blocking my way. Obviously, you can't see what's on my desktop. So what are the first thing I'll do? The first thing is I'm going to insert a new problem as always, okay? And for those of you who missed out all those videos, just make sure, the earlier videos that is, what it means to organize your work, even on the calculator, okay? So we're going to go through the menu, and you can either go via probability or you can go via statistics. In both those menus, you can see under probability that option 5 is distributions, and you can see the normal PDF or CDF, inverse normal, all those options are there. And the same way you could go via statistics, okay? And statistics, you have distributions number 5. Is it number 5 for both? Let me just check. And probability is number 5. Statistics is also number 5. Wow, great. So let's go via statistics. Distributions, normal CDF is what we're looking at. Okay, normal CDF is what we're looking at. And the low bound must be 45. The upper bound can be any high value. Normally in schools, we do that, right? We write down what the upper bound should be, and we just normally say that put some high value. But in the context of this question, what's the highest value possible? There's a total of 180 days, right? Total of 180 days. So even if you put 181, you know what? It's not going to make a difference. The answer is not going to make much of a difference. What's going to make a difference is that your understanding. Okay, I'm not sure whether that's going to be tested, but then, for those of you who are watching this and you want to really demonstrate an understanding that, hey, the total number of days is just 180. So why do you have to put something, more than 180? So the upper bound, I'm going to enter it as 180. I hope that is clear. All right, the mu is 35.5, and the sigma is 5.2. Okay, so although in the notation we have to enter sigma square, that's how the normal distribution is represented. The calculations, of course, in the calculator entering only sigma, and to make sure that the calculator is set to approximate mode, I'll do that quickly in a minute. I hope it doesn't move on, but never mind, we'll just do that. And that's the notation, and it gives me 0.034, but we need up to 3 SF, remember. Okay, so this is 0.338 up to 3 SF, and that would be 339 is what I should write up to 3 SF. Okay, so we can write it as am I sharing this thing? No, right? So let me come to this, and this is 0.0339 is what I'm going to write it as. Okay, and by the way, to avoid rounding off errors, because this is not the question, right? Part A is asking something else. Okay, part A is asking that find the probability that Louis is late on at least 10 days in the year. That's something else, not this. This is just, what is the probability that any one day is late on any one day of those 180 days? We got to find out that he's late on 10 days, right? So this is not the final answer, which means, there would be compounding error involved if you were to just use it as 0.0339. So I'm going to use all the digits available in the calculator, and I'll show you in a minute how I'm going to use that. So then what we are doing is that in part B, for part B, I'm going to just go and, make sure I continue here. This was all the working from the previous question. So if you run out of space, I've given the tip already what to do in the earlier questions. If you run out of the space, ask for another sheet of paper. Make sure you label it down correctly. So this is still part A. This is still part A, and I will say continued. Okay, continued, and this is question number 9. Okay, continued. So what are we doing? We'll say we'll now introduce a new variable and say let y be the random variable. Is this clear on the screen? Let y be the random variable representing the number of days, that Louis is late for school. All right, so you can see I've clearly distinguished x and y. X is the probability that he's late because that represents the random variable, the travel times, right? X represents the travel times. Y is another random variable that is talking about the number of days that he's late. That's a discrete random variable. It's a discrete random variable, and clearly we're looking at y to be, then we'll write it, then y is approximated by a binomial. Binomial is n comma p. N is the number of days. We're given in the question that's 180, and the probability of being late, that's the probability of being late. So 0.0339, I'll enter it there because it's 3SF, but I'm going to use as many digits as possible, okay, to preserve accuracy. So that's going to be 0.0339. Okay, this is important to know that we are using two variables here, okay, two variables. And then we say, what are we required? So the required probability for part A. What do they ask the question? Find the probability that Louis is late on at least 10 days in the year. On at least 10 days in the year. Required probability then would be the probability of y being greater than equal to 10. Is that clear? All right, y being greater than equal to 10. Notation, and this is a binomial. We've already said that, and therefore we can use a binomial probability on the calculator. Okay, so I'm going to switch to the calculator now quickly, and I'll say I don't want this one, right? So I'll just back up, back. Okay, and then we go through menu. This time let's just use the probability, and number 5 is distributions, and we are looking at binomial CDF. Okay, not PDF, CDF. Okay, and their number of trials is going to be 180. Probability of success, I'm going to enter it as 0.0339, and I didn't enter point, I put a comma, it would have given me an error. 0.0339. Low bound is 10. Low bound is 10, and the upper bound is 180. Again, I've explained how and why, okay, because total number of number of days, and that is 0.088. okay, and what is the 3s of 0.0875? I think we can enter it as 0.0875. What do you think? Let me know in the comments below. Okay, now one more tip quickly. So when you're showing the working, we have to say using GDC. Okay, because how did we get this is important, right? So we'll come to that in a minute. We'll come to that part in a minute, how we got that, what to write that. Here also we have to write using GDC and enter exactly what you wrote. What I mean by that is that, when you go to the screen, and if I go through the probability and the distributions, and what was that? The binomial CDF is here, and everything that you entered here, make sure you write it down on the paper. So it says number of trials, probability of success, low bound, upper bound, write it down. So using GDC, I'll just copy it down, but you know where I'm copying it from, right? And I want you to do the same thing for here. So I'm going to mention that, but I'm not going to write it down. I'm not even showing what I'm writing. So I'm going to write it for the binomial, but make sure you write it for the normal also. Okay. So using GDC, I can write down what are the things that I'm seeing. All right. I'm going to see num trials, TRIALS, N equals 180, and probability of success, you can write down P is 0.0339, and lower bound is 10, and the upper bound upper bound is 180, okay, and therefore you can see then probability of y being greater than or equal to 10 must be, what did we calculate? What did the calculator say? It says 0.00875. I'm keeping it to 3SF, okay? Maybe you can even mention that. I'm keeping it to 3SF. Hope you can see this. The same thing, I want you to do it for this one also. Make sure you write it down, okay? I'll use another color, okay? Using GDC, and explain what it means by that, using GDC. Okay? Don't just write the word using GDC. I'm doing it because, you know what, my videos are getting too long, writing so much, but you know what, I would have done it. But my basic idea is that I wanted to make sure that I offer the right tips. This part, you know how to do it because I've just done one for you. Make sure you write this clearly, okay? What are entries that you made on the calculator, you know? Because you know what, sometimes you can enter something incorrectly. And I'm telling you why, okay? If you enter something incorrectly and then you got an answer that is not the right value, at least the examiner knows that, you know, you've gone through the right option, and it's maybe because of examination pressure or whatever that is, you know, the time's running out, and you know, accidents can happen. You've seen in our previous video, right? So you may have entered something incorrectly. At least the examiner, you've communicated to the examiner saying that, you know what, I know the option where to find it. I know the features, and that's where you know, you may have entered something incorrectly, but you'll still get the points. And that is why I'm saying show it, okay? Show this part, okay? This is counting as working. I'm going to leave that as a homework. All right, so pause the video and write it down. We're going to go to the next part. Okay, that's equally interesting. It says Mrs. Beale is responsible for recording students who arrive late. Mrs. Beale is the person who's in charge for, you know, recording the students who arrive late. However, Mrs. Beale does not always accurately mark lateness. Yeah, I don't know why she doesn't that, but that's not the question, why she doesn't do that. It's not necessarily that she's favoring people, but she does not, okay? She does not accurately mark. On days when Louis is late, there is a 35% chance that Mrs. Beale will still mark him as being on time. That means there's a 35% chance that when he's late, when Louis is late, that he's going to be marked present, not as late, okay? So understand what's going on. 35% chance that he's still going to be marked as present even though he was late. Mrs. Beale's accuracy for one school day is independent of her accuracy of marking the other day. The same idea that, you know, the readings or the chances are going to remain consistent every other day. The probability of her marking, you know, like they say 35% chance of her marking him or anyone else as being on time is going to be remain the same, 35% every other day. Louis will receive a detention. Look at that. Louis will receive a detention if he is marked late to school. That means 1 minus or 100% minus 35. Okay, that's like 65%, 0.65. Okay, should be the probability that he is marked late. All right, when he is late, being marked late. Okay, so he needs to be marked late at least 4 times during the year. Okay, so instead of using many more variables, let's just, you know, without introducing a variable, I'll show you how to do this. We will introduce a variable for the final answer because, you know, he's got to be late and he needs to be marked late. Only then he gets a detention, right? So there are 2 parts to it. One is that he needs to be late. The chances of him being late is this. The probability that he's late to school, 0.0339. That's the chances of him being marked late. Of him being late to school. But of him being marked late is that 0.65. Because there's a 35% chance that he's not. So both need to be there for him to receive a detention, okay? But we need to find out, you know, that he's going to be receiving detention, remember, if he's marked late 4 times. So very interesting question, combination of several things. We're going to go and continue here or maybe towards the side here, okay? So that I can reserve the space for the next question whenever we solve that. Yeah, so this is part B. This is part B. And we will write down, okay, probability that Louis is late to school is 0.0339, okay, and that's from part A, We've already seen that using that normal distribution. Okay, my screen is clear. Cool. Now, according to the question, we have the probability that Mrs. Beale will mark him absent, will mark him as absent, late, not absent. Late is 1 minus 0.35. Okay, we'll leave it there, and that is basically 0.65. 65% chances that he's going to be marked late when he is late. All right, now then we can write down the probability what is it, if he arrives days to school on days when there is 35 chance that okay, accuracy of date, okay, receives detention if he's marked late to school. So I think we need to change the language a bit, because he's marked late, okay, if he's late and, right? So what we got to do, let's change the wording slightly, okay. Then and then comes Mrs. Beale's accuracy. Look at the language, okay? We'll keep the language consistent. Mrs. Beale's accuracy of marking him as late, okay? So Mrs. Beale's accuracy, Mrs. Beale's accuracy for marking him as late would be 1 minus 0.35, okay, marking him as at late, so that is 0.65, all right? Okay, so then the probability that Louis is marked late, he's going to be marked late on the day that he's late, right? So he needs to be late, which is 0.0339 times that 0.65. I hope this is clear, okay? Because see, he needs to be late, then Mrs. Beale has to mark him as late, okay? There's a chance, 35% chance that she might not. And then, you know, the probability that he's marked late, you know, literally he's on the record for being late is 0.0339 times 0.65. Now this is the probability that he's marked late on any one of those 180 days. Which means when we are asked a question like, you know, find the probability that he's going to receive a detention, he's going to be receiving a detention if he's marked late 4 times. So this becomes a new random variable, again a binomial random variable, because it's a number, a discrete random variable. So let's just work this out, this number out first, okay, quickly on the graphing calculator. If I can just switch that there. So what do I have? Let's just back up. This is not the number I'm looking for, and I'm looking for 0.0339. Maybe let's get a bit more accurate. You know what I mean by that is that we'll get all the digits. Here you go. You see, that's that probability of him being late on any one given day. That's the normal distribution. And then I'll multiply that by, you know, again, maybe just to preserve accuracy, 1 minus 0.35. This, you know, may not be applicable to this question, but I'm just showing it because there was an opportunity and you'll get a more accurate, ooh, that's an exact value, okay? So just pull it out and you can just hit Control Enter. Okay, there you go, 0.2022. What's the 3SF value for that? 0.022 again. Okay, so just we leave it there. And coming back to a question, we can write this value as 0.022. I'm going to write that thing. I show that earlier step there so that, you know, you just to show how you can bring back the as many digits as possible so that you can preserve accuracy, okay? I did that only for this part. This is the probability that Louis is marked late, and so we can say on any given day, okay? On any given day. So let's just say the new variable, then we can write down let we already used y, right? X is gone, y is gone. Let z be the random variable that representing the number of days that Louis is marked late for school. Okay, so this is a third random variable, and this is clearly binomial because it's a discrete random variable. So you got to put that thing down and say, therefore, Z is a random variable, a binomial distribution. N again is 180 because you've got 180 school days. The probability of him being marked late, as you said, on any given day is 0.022, 0.022, okay? And now what have we asked? We asked that, we asked the required probability. Instead of writing the whole sentence, you can just write down required probability means the probability of him receiving detention, okay? Probability of Louis receiving detention. And the question says that he's going to receive detention when this probability, that he's marked late for more than 4. Okay, so probability of Z being greater than or equal to 4. Let me just read whether it's 4 or more, or what is that? What does the question say? At least 4. Yeah, that's right. At least 4 means greater than or equal to 4. Okay, so this is a correct notation, and it's a binomial. We've said that. So let's jump to the calculator and put down these values that we have just found out. Okay, we are going to go through the menu again, and this time again we want to find the binomial. So make your way to binomial CDF. Maybe it's a good idea to even mention in the mention in your writing that you're using binomial CDF, because as I said, sometimes you may make an error in making the entries, but at least you're communicating to the examiner that you know that you're using the binomial CDF. Okay, so I will write it down here. Let's just put the values first here, okay, to show you. 180, and probability of a success we said is 0.022. Lower bound should be 4. Lower bound should be 4, and the upper bound is 180. You can write it down, and when I hit OK, I get 0.561. Let me just check that with the 3SF. It is, 561. Okay, so again, I'm going to come back to my working here, and we can say that using GDC, and you can write down N as 180, P is 0.022, the lower bound is, what do we have? The lower bound is 4, and the upper bound should be 180. Okay, so make sure that you've said that. And as I said earlier, maybe you could also include the phrase using GDC binomial CDF. Okay, so even if you made an error, because sometimes students are more worried about the final numerical value. I call that the final numerical value. Okay, so this is 0.561. This is just the final numerical value. This is what's considered as working. Okay, so make sure you enter these things. And I think that's all the time that we have for this particular video. Let me just check the timing. Okay, quickly, let me just check the time. I think we are about time. I'm so sorry. Okay, but that's all the time that we have for this particular video. So if you found anything useful, something useful, please make sure that you like, share this video with somebody, subscribe to my channel. If you visit my channel, you'll find plenty of other videos on my channel. Do check them out. And if there's any question, any topic, any concept that you'd like explained, do drop a comment and I will make a video for you.